Hi, I'm Randall Heyman, a university academic. If you'd like me to make you a quick turnaround video that would help you or your students with a mathematical problem or concept, just comment below any of my videos, or you can email me at coronahelpmathematics@gmail.com. So I've got an inquiry from someone in the US about what are the maximal ideals in Z10. Now I'm a little bit hesitant here to put the full solution, so what I'd like to do is give you a sort of a concrete way of sort of exploring ideals and maximal ideals to work this out. So let's just recall that Z10 is the set 0, 1, 2, 3, 4 up to 9. That's that set. We have addition and multiplication, and we'll just say that addition and multiplication are carried out modulo, I suppose I should write out there, carried out modulo 10. Example, 3 plus 8 is equal or equivalent to 1. 3 plus 8 is 11. We're doing it modulo 10, so the remainder is 1. 4 times 7 is equivalent to 8, because 4 times 7 is 28. So that's what we're dealing with. Now, the first thing I would suggest here is let's try and just find an ideal, let alone a maximal ideal. So what's the concept of an ideal? So remember what we do with an ideal. We have to find some set that when we multiply it by every element here, every element in the set, well, we stay in this set down here. So I'll give you an example. Let's say we thought that it would be 0. Let's try. So what I'm saying is, just in terms of process, find an ideal in Z10. So I'm not worried about the maximal at this point. I'm just saying let's try an ideal. Now 0 by itself is an ideal. Why? Because 0 times r, where r is an element of z, well, actually, let's write it this way. 0 times r equals 0 for all r in Z10. Yeah, okay. What about if we do, let's start one with 0 and 1. Well, the thing with 1 is, 1's special because once we have 1, we go 1 times 2 equals 2, 1 times 3 equals 3, 1 times r equals r for all r in Z10. So once we have the number 1, we have to extend it all the way up to 9. But this is an ideal. This is actually the ring itself. So the ring itself is an ideal. So how could we construct another one? Well, let's try. We said once we've got a 1 in, there's no point sort of going on because we'll have the whole lot. But we do need a 0. So we could put 0 and let's try 0, 3. Well, what have we got? We've got 3 times 2 is 6. So we better put a 6 in. Now we've got 3 times 3 equals 9. So we better put a 9 in. Now once we put 6 and 9 in, the same thing applies. So we can now look at what's 6 times 4 is 24. So it's equivalent to 4. 6 times 4 is 24, so that's 4. So I've got 4. And I think you can see pretty quickly we're going to have to put everything. Once we've got 3, we've got the 3 there. So we go 3 times 7 is equivalent to 21. So we get 1. And of course, once we get 1, we get all of them. So it'll be all of the. So this is starting off. So what I'm saying is 0, 3, starting 0, 3 gives the whole ring, which we had before. So this would be a good chance to sort of think about, can you come up with it? Can you create an ideal in Z10 other than the 0 was set with 0 and the Z10 itself, the ring itself, which is equal to 0, 1 to 9. So I think that would be a really good exercise for the person who asked me this question. Try and come up with any sort of ideal at all. I'll give you a clue. For 10, there's 2 other ideals. So I would suggest you see if you can find them. And just to fill you in, when I said let's start with 0, 3, I'm not suggesting that all the ideals just have to have 2. You could have an ideal with 3 or 4 or 5 or 6 potentially. So when you're checking, you might want to try, I don't know, what about 0, 4, 8? I mean, there's no reason why you have to have just 2. This would be an ideal of 3. Anyway, play around with it and see what you come up with. Comment me below. It's probably the best, and we'll explore this a little bit further if necessary. I think once you've got the ideals and you can see that you've got all the ideals, it's then pretty straightforward to check whether they are maximal ideals. That's a separate issue, but I think that'll come readily once you understand how to find the ideals of Z10. Any questions on any branch of mathematics or any concepts in mathematics that you or your students are interested in, then comment me below or drop me an email at coronahelpmathematics@gmail.com.